Hey, and welcome back to Stats and Stuff. This is Taylor. We are going to take a look today at a couple of problems that we haven't looked at how to work before, which is if you're given an area or given a probability, how to go in reverse or do the inverse and find the X value that would give you that particular probability. So for example, let's say we want to work a IQ problem where the mean of the IQ test is 100 points and it has a standard deviation of 15. We want to come in and say, a normal problem would be something like, what is the probability of someone getting above 115 on the test, right? We know how to work that. We follow our 4-step process. But what if we wanted to come in and say, what is the score of the top 10% of people, right? What's the cutoff score to be in the top 10%? That's a problem we haven't worked before, but we can do it using the exact same tools that we have already. So let's actually work that one particular problem, and then we'll jump over into the textbook that we've been looking at. But let me just flip on my writing screen here. Okay. So what we just said was, let's say we have an IQ test. Let's see. So IQ test where the mean of the test is 100 and the standard deviation, so sigma, is 15. So again, we can draw this out. All right, here's our normal distribution. And it has a mean of 100. And we want to know, what score do you have to have? So here's some score to be in the top 10%. So this area right here is 0.1. We want to know, what is X? What is that cutoff score that you have to be into the top 10%. Maybe we're trying to get into some kind of elite academic organization, and they say to get in here, you have to score in the top 10% of all people on this IQ test. Well, how do they know what score to actually find that at? So that's what we're going to go and figure out. So we're essentially going to work our 4-step process in reverse. Okay. So in this case, we already have the area, right? If you think about the whole thing that we're trying to do in the first, in those first problems that we're working, is find the area. Well, we already have an area here. The area is 10% or 0.1. What we're trying to do now is find the X, which is usually given to us in the problem. So we're going to kind of work those 4 steps in reverse. So the first thing that we're going to do here is we're going to look at the area that's given, and we know that our z-table always gives us the area to the left. So we need to turn the area that we have, 0.01, into the area that we're going to be able to find in our table, which is the area to the left. So we need to know, what is this area, right? We need to be able to come over here and say, if we wanted to find this red shaded area here, how do we do that? Well, again, it's pretty straightforward given what we've talked about before. We know that the entirety of the normal distribution, kind of this whole thing here, is 1. Okay, so if that whole thing is 1, we know we have 0.1 to the right. That means to the left, to the left here, we have 0.9. Okay, if you got 0.1 to the right, you have 0.9 to the left, you add them together, and you get a total of 1. So now, we're looking for an X value that is higher than 90% of all of the values, which makes sense, right? It's lower than 10%. It's higher than 90%. So we need to go figure out, how do we find this? Well, we're going to go look at our z-table. So let's come up here and look at our z-table. Now we're going to do this a little differently than what we've done in the past, because at this point, what we have is the area, and we need to find the z. Now that's backwards from the way we usually use this table. We usually look up a z-score and find the area. But in this case, we need to look up an area and find the z-scores. The area are these things here in the middle. So we need to go find 0.9. So we're going to scroll all the way through it. We see the area, the ones to the left, they're all below 50, which makes sense. So we need to go to the right, or to the next set of the tables, and find the one where the area to the left is 0.9. So we're going to get as close as we can. You're never going to be able to get it exactly. Well, usually you won't. But you want to find the one as close to it as possible. So we'll come here and we'll say, okay, here is, right over here we have 0.8997. That is 3/10,000ths off from 0.9. The next one over is 0.9015, which is 15/10,000ths off. So the closest one is this 0.8997, and that comes from a z-score of 1.28. Everybody see how we're getting that, right? We go find the area that's closest to what we're looking for, that 90%, and we say what z-score gives us that area. It's 1.28. So then we know, coming back over here, that the z-score for this x is 1.28. But that's not the end of the problem yet, because just because we know the z-score, that's not the score on the IQ test, right? If you got a 1.28 on the IQ test, you're not doing very good, okay? We need to find out what score on the IQ test is 1.28 standard deviations above the mean. That's what a z-score tells us. So we're going to go use our z-score formula that we've used a ton, okay? And we're going to say that z is equal to x minus mu over sigma. And now we're just going to plug in what we know. Well, z is 1.28. That's equal to x, which we don't know. Mu is 100. And sigma is 10. Now we can come through here and solve this, right? So we can say, let's multiply both sides by 10. And so we get 12.8 is equal to x minus 100. Let's add 100 to both sides, and we get 112.8 is equal to x. So x here, this line, is at an IQ of 112.8. And that's our answer. So on an IQ test, if you score above 112.8, you're in the top 10%. Okay? All right. So that's the way that we're going to work this, right? We're essentially working this in reverse. Let's walk through kind of what we did. We found the area to the left that we need to look up from the area that was given to us. We went and looked up that area and found the z-score, kind of in reverse using the z-table. And then we used our z formula to come in here and solve for x. So it's kind of working steps 2, 3, and 4 in reverse, going 4, 3, 2. All right. So let's work another one. This is going to come from our example that we were working the other day. So here we're going to look at bottled water in Spain and say the mean of that is 32.1 gallons. The standard deviation is 8. But here's what I want to look at right here. What is the probability? Oh, excuse me. We're going to look at D. 90% of the people in Spain consumed less than how many gallons of water? 90% of people in Spain consumed less than how many gallons of water? So this is going to be very similar to the problem that we just worked. So let's come over here and let's draw this out. Okay, so here we're dealing with water. We know that, let's see, mu was 32.1 and sigma was 8. So let's draw our normal distribution out here. Here's 32.1. We've got a thing over here where we're looking for x. And we're looking for 90% of the people consumed less than this value. So this area here, right, that whole area is 0.9. Okay? Well, this is basically the same problem that we worked a minute ago, because if you come out here and say, okay, well, we in this case, we don't have to do any weird stuff. It's already given us the area to the left. The area to the left is 90%. So if the area to the left is 90%, I need to go look up a z value where the area to the left of it is 90%. We did that just a second ago, right? That's the exact same problem that we worked. Let me just show you again. The area to the left is 1.28. Sorry, the z-score is 1.28, and the area to the left of that is 0.8997. So again, this is the same z-score. Oops. Z-score is 1.28. Okay? So with a z-score of 1.28, now I can come up here and use my z formula. Z is equal to x minus mu over sigma. So 1.28 is equal to x minus 32.1 over 8. So now this is where the problem differs, right? Because we have a different mean and a different standard deviation. So our x is going to be different, okay? So we multiply both sides by 8. So let's see, what is that going to give us? 8 times 8 is 64, carry the 6. 8 times 2 is 16, plus 6 is 22, carry the 2. Let's see, 10.24 is equal to x minus 32.1, and you can do that with a calculator, obviously. So we come here when we need to add 32.1 to both sides, and so we come up to find out that x is equal to 42.34. So 90% of people in Spain consumed less than 42.34 gallons of water. Okay, so the only way this problem differed from the previous one, so we had a different x. Well, yes, we have a different x because we have a different mu and a different sigma. Okay, so let's go in and let's work another problem. This time taking a look at Fly High Airlines. So Fly High Airlines determines the distance traveled per aircraft per year is normally distributed. Great. With a mean of 60,000 miles and a standard deviation of 10,000 miles. Let's go down here to look at C. How many miles will be traveled by at least 70% of the aircrafts? Okay. So we want to find where the cutoff is for 70% of the aircrafts. So let's come over here and draw this out. So we know that the mean is 60,000. Sigma is 10,000. Here's our standard deviation. Excuse me, our normal distribution. Mean is 60. And we want to find the x value where the area to the left, that area there, is 70%. So we want to find the cutoff such that 70% of flights fly that distance or less. Okay? So how do we do that? Well, the first thing we need to look at, this is kind of, again, going in reverse, step 4, do we need to figure out any different area? No, we don't, because this is giving us the area to the left. And our z table gives us the area to the left, so we don't need to do anything funny there. Okay? The next thing we need to do is we need to go out and look at our z table to find an area of 70%. So let's go find our z table. And we're going to come in here and we're going to find an area of 70%. So we're going to come through here, just look through it. It goes in order, right? And we see right here, there is a 0.6985 and a 0.7019. In this case, they're about equally distant. This is 15 ten-thousandths below. This is 19 ten-thousandths above. So technically the closer one is the 0.6985. So let's go with that one. Ask your professor or your teacher how they would want you to handle a situation like this, where they're very close, kind of right in the middle. Some people will have you take the average of the two. I'm not going to worry about that today. We're just going to take the lowest, or the one that's closest, which is the 0.6985, which is a z-score of 0.52. So a z-score of 0.52. So let's come back over here. And what we find out is that then our z-score, we said, was 0.52. Okay, great. So with that in mind, we need to find what is the x value that has a z-score of 0.52. So we're going to come just right up here and we're going to say, write out our formula. Z is equal to x minus mu over sigma. 0.52 is equal to x minus 60 over 10. Multiply both sides by 10, and you get 5.2 is equal to x minus 60. Add 60 to both sides, and x is equal to 65.2. And that's your answer. So 70% of flights fly 65,200 miles or less, right? That's what our piece here is telling us. Okay, let's do one more, and then we'll call it a day. Let's see. Let me find another one here. Okay, so let me bring this back over so we can see it. A Nielsen study indicates that 18 to 24-year-olds spend a mean of 174 minutes watching videos on their smartphones per month. Assume that amount of time is on a smartphone is normally distributed, and that the normal standard deviation is 15 minutes. Let's come down here to the bottom. 1% of all 18 to 24-year-olds will spend less than how many minutes watching video on his or her smartphone per month. So what we want to take a look at is the bottom 1% will spend how much, right? Okay, let's actually do both. I think it'll be fun to say, what does the bottom 1% do, and what does the highest 1% do? Let's figure out both of those, okay? Because we haven't done one of the top ones yet, coming from the problem. So let's clear this out. Let's make sure that we write out what we had. So coming back over here, our mean is 174 minutes, and our standard deviation is 15 minutes. So let's draw our normal distribution. Our mean is 174, right? And we want to find the lowest 1% and the highest 1%. So we're just going to mark that as X1. We're here to mark this X2. So this area here, that is 0.01. And that area there is 0.01. Okay? So we want to find the x's that cut off the highest and the lowest 1%. Okay? Now, to do that, let's start with the easier one, which is going to be x1, because we need to know the area to the left. Well, the area to the left is 1%, right? It's given to us right there. The area to the left of x1 is 1%. So let's grab our z-table, and we're going to go find 1%. And it's going to be way up here at the top. It's 0.01. So let's come over here and find 0.01. The closest to that right here is 0.0099. That's only 1/10,000th off. And that is a z-score of negative 2.33. Negative 2.33. All right, so let's come back over here and say that this is a z-score of negative 2.33. Now, some of you might already know what the z-score is here, but if you don't, let's think about it for a second. The area to the left is what? 99%. If the area to the right is 1%, the area to the left is 99%. Let's go look that up on the table. So I'm going to come down here and look for 99%. And 99% is going to be right here, right? 0.9901, 1/10,000th off, and it is a z-score of 2.33. Okay, so the z-score here is 2.33. Well, wait a minute. That's just the positive value of the negative 2.33. And why is that? Because the normal distribution is symmetrical. So it is the same distance away from the mean. The top 1% and the bottom 1% are the same distance away, and therefore they should have the same z-score. Just one is negative, which means it's below, and the other one is positive, which means it's above. So the z-scores are essentially the same number. They have the same absolute value. They're the same distance away, okay, which is the 2.33. So now that we know what the z-scores are, let's go out here and work it. So let's work this first one over here. And we will, I'll work it up here. So we'll say z is equal to x minus mu over sigma. In this case, we have to write the whole thing out. So that's going to be negative 2.33 is equal to x minus 174 divided by 15. So we need to do 15 times negative 2.33. So 15 times, we'll call this a third, is going to be 5, right? 15 times 2 is 30, so this should be negative 35. So that's going to be negative 35 is equal to x minus 174. Now we need to add 74 to both sides. So negative 35 plus 174 is equivalent to 174 minus 35, right? Which is going to be what? Okay. So I'm going to write that out. So that's 174 minus 35 is equal to x. So let's just, again, I'm going to kind of walk through how I do this mental math. So picture this as being 175. 175 minus 35, right, would be 140, but it's going to be one less than that because I added in that, so this is going to be 139. 139 is equal to x. So our x down here is equal to 139. The lowest 1% of people, of the 18 to 20, I think it said 18 to 24-year-olds, watch about 139 minutes per month of content. Now let's go find the highest over here. Well, to do that, we're just going to redo that same problem again. Z is equal to x minus mu over sigma. What is that? So 2.33 is equal to x minus 174 over 15. 15 times 2.33 is then 35 is equal to x minus 174. Now I'm going to add the 174 to both sides. So 174 plus 35 is equal to x. This is going to be, let's say, 170, the 30, that's 200, the 4, so that's 209. And there's one answer. There's the other answer. All right, so let me write that on here. So the top 1% watches 209 minutes or more. The bottom 1% watches 139 minutes or less. Okay? So again, we can use, this is sometimes referred to as the normal inverse, right? We're essentially working the problems in reverse, or you're using the z-table as an inverse lookup table. You're going from the area to the z-score instead of the z-score to the area. Okay, so you'll find, if you're using Excel or something like that to find these areas, you're using the inverse function. I'll make a video of how to do all this in Excel, but I personally like using the z-table because it just fits in with the probabilities really well. So thank you guys for watching stats and stuff, and hopefully you will like and subscribe to the videos. We'll have a lot more stats content coming. Feel free to comment below if you have any questions, and we'll get right back to you. Thanks a lot. Have a great day.